What kind of computer could solve problems that even the fastest supercomputers in the world struggle with? The answer lies in quantum computing, a technology that uses the strange and powerful rules of quantum physics to calculate in ways we never thought possible. Unlike regular computers that process one solution at a time, quantum machines can explore countless possibilities simultaneously. In this video, we'll uncover how quantum computers work, what makes them different, and why they might completely reshape our future. So, without any further delay, let's get started. The birth of a new era in computing. For decades, classical computers have powered our digital world. They run everything from phones and Karsto satellites and massive data centers. These machines rely on bits, the smallest unit of information, which can only be 0 or 1. This simple system has worked well, but as technology advances, we face problems too big for classical machines to solve efficiently. Weather prediction, drug discovery, and advanced AI require processing beyond current limits. This is where quantum computing enters the scene. By using the strange but powerful principles of quantum mechanics, scientists are building machines capable of solving problems once thought impossible. It marks the beginning of a new era, one that could transform industries and redefine how we think about computing. From bits to qubits, a different language of information. The major difference between classical and quantum computers lies in how they handle information. Classical machines use bits, which are like light switches, either on 1 or off 0. Quantum computers use qubits, which follow quantum physics. Thanks to superposition, a qubit can exist as 0, 1, or both at the same time. This ability means quantum computers can perform many calculations simultaneously instead of one after another. Imagine trying every possible route on a maze all at once rather than testing one path at a time. That's the advantage qubits bring. The more qubits connected in a machine, the more powerful the system becomes, creating opportunities for breakthroughs in fields where classical computers struggle. The magic of entanglement. Another quantum property that gives qubits their power is entanglement. When two qubits become entangled, the state of one immediately affects the other, even if they're far apart. Albert Einstein once called this spooky action at a distance, but it's a proven phenomenon. Entanglement allows quantum computers to connect qubits in ways that supercharge processing ability. Think of it like a team of dancers moving in perfect sync, no matter how far they are from each other. This coordination lets quantum systems perform complex calculations more efficiently than any classical machine. Without entanglement, quantum computing would lose much of its advantage. Together with superposition, it forms the foundation of why quantum computers are so much more powerful. Quantum algorithms, thinking beyond limits. The real magic of quantum computing doesn't just come from qubits. It also comes from the algorithms that guide them. Classical algorithms solve problems step by step, but quantum algorithms use qubits' unique powers to test countless possibilities at once. For example, Shor's algorithm can factor massive numbers, something classical computers struggle with, which could challenge modern encryption systems. Another famous example is Grover's algorithm, which speeds up searches in large databases. These algorithms reveal why quantum machines are considered game changers. They're not just faster, they think differently. By reimagining how problems are solved, quantum algorithms unlock possibilities far beyond today's computing, from cracking codes to accelerating scientific discovery in ways previously unimaginable. Medicine and materials. Quantum computing has the potential to revolutionize medicine and materials science. Today, simulating molecules with classical computers is extremely difficult because of the countless interactions between particles. Quantum machines, however, can model these interactions with incredible accuracy. This means faster drug discovery, more precise treatments, and even breakthroughs against diseases like cancer or Alzheimer's. Beyond healthcare, quantum simulations could create lighter yet stronger metals, more efficient solar panels, and powerful new batteries. Imagine electric cars with ranges 3 times longer or planes that consume far less fuel. Quantum technology could make these ideas reality. By unlocking secrets at the molecular level, quantum computing offers not just a healthier tomorrow, but also a cleaner, more sustainable world. Artificial intelligence gets smarter. Artificial intelligence is already transforming how we live, from voice assistants to self-driving cars. But training advanced AI systems requires analyzing huge data sets, which takes time and energy on classical computers. Quantum computers can dramatically speed up this process. By processing multiple possibilities at once, they could help AI recognize patterns, make decisions, and learn more efficiently. This opens the door to smarter robots, advanced medical diagnosis, and AI tools that can solve global challenges like climate modeling. A future where AI and quantum computing work together could mean breakthroughs in areas we can barely imagine today. By combining the creativity of AI with the power of quantum systems, we may unlock the smartest machines ever built. Optimization. Optimization is everywhere, whether it's airlines designing flight schedules, delivery companies planning routes, or manufacturers organizing supply chains. These problems often involve millions of variables and possible solutions. Classical computers can only try them one at a time, making some tasks nearly impossible. Quantum computers thrive in these situations because they can evaluate countless possibilities simultaneously, quickly finding the best one. For businesses, this means reduced costs, saved time, and less waste. For consumers, it means faster deliveries, cheaper goods, and smoother services. Imagine global trade routes optimized in real time or energy grids perfectly balanced to avoid blackouts. By untangling these complex puzzles, quantum computing could make our world far more efficient and sustainable. Financial services and security. The financial world depends on analyzing risks, predicting trends, and making split-second decisions. Quantum computers could revolutionize this by simulating market scenarios and stress-testing systems in ways classical machines cannot. This means more accurate forecasts and better investment strategies. But there's also a challenge. Quantum computers could break today's encryption methods, which secure everything from bank accounts to online messages. That sounds scary, but researchers are already developing quantum encryption, which uses the laws of physics to create unbreakable codes. This means future financial systems may not only become smarter but also safer. With quantum computing, the world of money and security could enter an entirely new age of trust and innovation. The road to quantum advantage. Even though quantum computing is powerful, it's still in its early stages. Current quantum machines are limited. They require extremely cold environments, and qubits can be unstable. But progress is being made. Scientists call the moment when quantum computers outperform classical ones in certain tasks quantum advantage. We're starting to see hints of this already in specialized experiments, like solving math problems classical systems struggle with. However, large-scale, practical quantum computers may still take years or even decades. The journey won't be easy, but each breakthrough brings us closer. Just as early computers once filled entire rooms before shrinking into our pockets, quantum machines will evolve into tools that change everyday life. The future of super-powerful machines. The future shaped by quantum computing could be extraordinary. Imagine doctors developing cures in months instead of decades, or energy systems optimized to cut waste and lower costs. Artificial intelligence could advance far beyond today's limits, becoming a true partner in solving global challenges like climate change or space exploration. Quantum simulations may help design spacecraft materials, predict planetary environments, and even improve agricultural methods worldwide. Much like electricity or the internet once transformed society, quantum computing could redefine what's possible. These super-powerful machines represent not just faster technology, but a complete reimagining of human progress and innovation. Quantum computing is more than just advanced technology. It's a window into a future where we can solve problems once thought impossible. From transforming medicine to reshaping industries and strengthening security, its potential is extraordinary. While challenges remain, progress is moving us closer to that reality each day. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into technology. Thanks for watching. Until next time, stay curious and keep exploring.